Okay. This is just something that occurred to me during Jakob's CI talk yesterday. But so I'm Matt Martineau. I'm one of the multipath TCP maintainers, and wanted to plug some work that my co-maintainer Matthew Barretts has done on the CI side. So we're a pretty small open source group, but we have our own mailing list. We review patches there, validate them in our own Git repo, and then either Matthew or myself forward those on to Netdev. But we are running our own CI, really without any corporate sponsorship. So anyway, in terms of quick hacks, what you can do, if you look at mptcp.dev in the contributor section down at the bottom, Matthew has a link to his, I think it's mptcp virtme ng. But he's set up a virtualization, a way to automatically build and run kernel unit tests using just GitHub actions. So at the beginning of this year, GitHub changed their policies on the runners, so you can actually run, hardware KVM instances. So we can build a kernel, run that kernel in KVM free on GitHub, and run our own CI. Do a lot of the similar things to what Jakob does there, but might be of use for other maintainers. Maybe not so much for drivers, but certainly protocol type stuff.
That sounds super interesting. So can I ask a clear? Well, I guess I will just ask. So are you like selecting what is running on the runner, or is it just exporting dev KVM to the runner so you can run like KMU with hardware acceleration?
So yeah, we build the kernel and then just hand that off to the virtme ng.
They run this,
tool. And they run this, point to mount this file system, run these kernel tests. That's how things go.
Really, that's super interesting.
Yeah.
Wow. Cool. Thanks for that.
Yeah. Any other questions?
Thank you. It would be nice to have shown a demo, but thank you.
I just realized that I'm going to have to try and hold a mic and type, which is at all.
You want a lapel?
I want a lapel mic, even though they're not going to work. We'll make it work.
Do you have a lapel mic? Yeah.
I got to get set up anyway.
Are you indicting?
Okay, that'll work. The technical problem solved.
Hardware.
What do you guys think? Does this work? Hear me?
Kind of.
Kind of. Okay. I think maybe if you show my screen, I will share. Hey, now we're talking. Okay, given that I haven't really thought about doing this before about 10 minutes ago, we're just going to go for it. I mentioned this trick to somebody earlier today, and they said they didn't know it, so I thought I'd share. The idea here is that I have a tree that's relatively, let's pretend, up to date, because I didn't check it real closely. The idea is that I'm going to show you two tricks all at once. I have a kernel tree. It's just a Git tree. It's pointing at netnext or something from April 30th, 2024. No big deal, right? The directory does not have a .config file in it. Okay. And I have another directory that I created already that I have all my object files in. So you can compile your kernel with different personalities and different config files and different object directories. I'm not sure if you guys are aware that you can do this. It's kind of a lost art, I feel like sometimes. And sometimes it breaks horribly when you try to do stuff. So you can say make O equals and then pass it a path. and I'm going to tell it to do my normal config obj directory, right? And this is actually where the .config file is, and it's going to use that config file and start a build. You can use this to do cross-compiling, so you can set up .config files in that other directory with other compilers and other CC equals options and other stuff, and all your objects go over there. This is actually kind of nice if you don't like having your kernel Git tree polluted with lots of data. One way to manage it. It creates its own set of problems, but you can totally like do all the things with make o equals blah, blah, blah. I can say make o equals install modules install, and it'll try and go do it all, right? In this case, you see it biffing because I'm not running the because I'm a developer. So the thing I wanted to show you was that I can build my driver module with this trick, right? And test builds, do all the other things that I would normally want to do. I can even load modules from that directory if I boot from this kernel, like if I did a make install. So you can do all your development tricks. So that make o equals thing is the one thing that I wanted to mention. If you haven't tried it, you should mess with it a little bit. It's kind of cool, like I said, because you can leave already built sections of the kernel on your disk and have a whole bunch of them at once instead of having to switch your entire kernel over every single time you want to do.
It's actually a little easier than that because you can just change directory to that, right? And
Just like
run.
that.
Yeah, and now you can run make without the o equals.
Yes, you can. Right.
So
But
it's
if I want to
easier that
edit
way.
the files, I have to say vim ..
Pardon?
If I want to edit my files, I have to say.
Oh, well, yeah, right. So
Take your pick
Yeah.
about. I hope everybody knows how to use CD. Let's not talk about that.
like use two terminals or something. Right.
Yeah. So the other one I wanted to show you was, did you know that the kernel build system, kbuild, knows how to build intermediate files, and you can tell it to do so. So I'm going to do it from within this obj directory, and I'm going to say make an intermediate file. And when you pass a file name with a .i extension, it will build that intermediate file for you. So I already did this to make sure it worked just a few minutes ago. See, I was practicing my demos. I did an RM. That's not what I wanted. So else if I look at the commands. The point is that now that I did this, I can go look at this intermediate file that has all my junk in it of my code, and you can see all the macros expanded, and you can see all the pass one complete stuff. So this is really useful actually when you're debugging and you're trying to figure out what the hell just happened with this stupid macro. Now all the macros have been expanded, and the file you can see is 149,000 lines, right? It's one of our C source files. It's like 10,000 lines source file. So having this intermediate thing is a useful debugging trick if you've never used it. There's other ways that you could have gotten this intermediate file by being super tricky with GCC and C flags and a whole bunch of other things, but make blah, 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 .i is super. So I wanted to share that. And you can also see all the includes and all the files that were generated, or all the things that were generated out of all the macros, and it goes on and on and on. And you can see ICE probe and find out that, what the expanded code all looks like when it's all generated. I don't know if that's interesting to you, but it has helped me a whole bunch many times in my career trying to figure out what the heck just happened with my macros or with something else or with some sort of generated code that we had, because we do have a lot of Johannes K-compat code and that is messing with macros, and sometimes it breaks on older kernels if you're running an out of tree driver. And I know no one's a fan of those, but they're a reality of life for us. So that's that. All right. So I think those are the two things I wanted to talk about. The other one is that I wanted to show was, I don't know. I find it interesting to look at other people's development environments sometimes. I actually run almost completely within Tmux on Windows, SSHing into my Linux machines. It is a fantastic setup, and it supports X Windows seamlessly, so I can just run X commands and they pop up on my Windows machine. It's very nice. And you can support the guys that write Tmux by actually giving them money, which is also nice, especially for supporting other software developers. So the way that I've set up things is I have these directories, right? And if I edit a file, I'm just going to show you my Vim environment and what it looks like. I have a Vim file that is colorized and shows tabs and trailing white space. And I stole this from somebody else. It's Ketku from a million years ago. But the whole idea is this helps me be a more efficient editor and developer because there's all this code and the white space is shown and colors are reasonable for my tastes. And I don't expect you to like them because everybody's taste is different. The thing that I do really like is the Fugitive plugin. I'm telling you about this. It's a Git plugin for Vim, and like I just ran git blame on this file, and it's showing me in the left window all the commits that have changed each of these lines in this file, and I can click on one with my, moving my cursor to it, and then click on a commit like one from Jake, and it'll show you the commit itself. You can move around and click on the lines, and you can actually click on lines that weren't part of the commit and hit enter again, or ones that were removed, and it'll show you file at the point that was added. So now you can look at the file with that commit applied. This is all kind of useful and quick, stays in my editor. I'm not exiting out into shell and stuff. I don't know if this is news to anybody, but I'm just showing you what I do. This is how I kind of get around. And this is what I use in my development environment.
And you have to take to it. This is how my foo. This is my foo.
This is my foo. You don't have to like it though.
Pig on the command line you do have to get out of your editor does the same thing.
I totally agree.
Yep.
But
In case you want another tool.
I like hanging in my editor. Yeah, I know about Tig because Jake uses it.
Yep.
I think Jake uses it in editor.
I think you can use that.
The only other one that I use all the time that I don't know if everybody knows about is running make inside Vim. It uses scratch buffers. When you have this all set up and it works right, amazing. So remember that normal config thing that I was talking about? Gosh, sorry for the flash. You can run make on files and drivers and kernels and whatever, right from within your Vim prompt, and then go look at the compile output right in Vim. So I don't leave Vim very much, right, even during my development process, right? So I make file changes, I build in thing, I go fix errors that are hit, especially in kernel. Right there, it uses this scratch buffer to go find the errors, and then I can just progress through them and fix them all one after one, hit make again, et cetera, et cetera. I don't know if that's useful to you. I hope so. I think that's probably enough for me talking. And, I've got other tricks, but those are the ones I thought I'd share right away.
Amazing.
It's something.
Is that all the foo you have?
My foo is exhausted. I presented today.
So you're getting pretty close to Space Max, which is a pretty big project in Emacs, but it's created by people that love VI, right? So everything is accessed modally, with the spacebar being the entry key. So you hit space, and then there's no control key things going on like Emacs normally, right? So it's for real VI lovers, but you start getting into things like they call it Magit or Magit, M-A-G-I-T, is very similar to what you just showed, the same sort of powerful, like just click and it's, all at your fingertips. Mm-hmm. So just anybody out there that, if you like this, but you want it a little bit easier to have it all set up for you, you can start with something called Space Max. It's pretty cool too.
Yeah, thanks for the idea.
Yeah.
You can demo it for us if you'd like. You can demo it for us if you'd like.
Yeah. Okay. Maybe if there's time, but I did one last time, so
You can foo.
no, I fooed last time.
It's both a verb and a noun.
I don't know. Does anybody have a question or a thing that, based on the kind of looking at the environment that I was just generated? I'd be glad to answer a question or even try and do something crazy. Maybe you can teach me something. I'd love that too.
Come on.
Teach Jesse something. I dare you.
All right. Somebody. You want to go up there? You're going to give a demo? Oh.
I have a little one, just I'm an Emacs user. But git gutter is super helpful too. So when you're going through all the code, especially when you're collecting a bunch of changes, you can easily see.
As it turns out, I have it installed.
Awesome.
Yeah. So if I make a change here, to the file. Let's say I change this if to something else. Oh, there's get gutter popping up showing it's been edited line. You know, CD on instead of an if, it's going to work great, right? But yeah, this is kind of cool. You can, with get gutter, this little thing on the left over here, I don't know if you can see my mouse very well, but on this line right here, there's a little character that popped up in the left on this gutter now that just appeared when I started editing. And it shows cool stuff like added and deleted lines. So if I delete some things, it shows that I deleted some stuff. And if I add some lines and not just change them, no, this is a good test. You know, it's showing that those are edits. And in fact, if I go somewhere else in the file and use get gutter to do, you know, some changes up here, add some lines, and I can hit like square close bracket D or whatever or down, and it will jump to the next change. So I don't know why C. And I have it in my head that that's the right thing to hit, but then when I explained it just now, it didn't sound right. So anyways, but it jumps to the next change. So you can like flip through the changes in your file that haven't been committed yet. That's pretty handy. Thank you for the get gutter suggestion. It's brilliant. Yeah, and like I said, I have it. I don't have that many plugins. I run Vim with the customized Vim RC and get gutter and the what do we got? Auto load, colors, doc, pack, plugin, spell, syntax, test, Vim. How much? Where's the plugins hanging? My plugin list.
What?
CVS command. That one's hanging out from old times.
Oh, somebody on the mic?
Hey,
oh,
somebody's on the
remote?
bridge.
I think there's somebody remote.
Somebody's yelling what?
Somebody remote? No. Yeah.
The other, have you guys ever used ripgrep? Have you heard of it? Oh my God, I love it. I have it integrated in the git command or the grep command in Vim and in git grep. So it just runs git grep very seamlessly and does exactly what I want, except 100 times faster than all the other grep commands.
Are you using tags and cscope in there?
Yeah, I use C tags. A lot of people like cscope, but I never got into it. I'm old school.
Setting them both up is pretty easy.
Yes,
Thanks for bouncing around the kernel.
really love C tags because you can just hit a square bracket and they'll jump to the definition of whatever I just was on top of. Test bit. Oh, here's all the test bits. Oh wait, let me go look at number one. Okay, there's some, you know, usage or definition of test bit, which is not the right one. So I'm gonna keep popping through the list.
Some grateful.
Yeah, and I like the audience participation. You guys got any more? Oh, yeah. You guys can use Emacs. I'll really encourage you to go do that, but not for me, sorry. Actually, I use Thunderbird. It's the easiest way to get into the middle of it from combination of Windows and Linux setup like I have. I have set up Mutt before. I've used it. It's okay to read mail and stuff, but I never really got into it. For a while, I used Evolution running on Linux. But I found that Thunderbird running under Windows or Thunderbird running under Linux gives me a nice unified environment, and I can expand the config to multiple machines by just copying it. So I have my Thunderbird set up and I just kind of port it around. It works great. I have two plugins installed. One is the auto review plugin and one's a threading plugin. Does some threading in the preview window, but nothing fancy, just two quick little plugins. It works good enough for me. I think the other trick that I did that's really, really helpful is the finding patches that haven't been reviewed with kind of a complicated search in Thunderbird. So I can hit a folder that has unreviewed patches. Like, we find things to target. Thunderbird colorized the diff. I don't know. I mean, we could go look, but I don't really want to share my email, so thanks.
It seems there's a plugin for it.
Hmm?
It says there's a plugin.
There's a plugin that you can install and it coloralizes everything in Thunderbird. Very nice.
Yeah, there's a plugin for that.
And I think it needs to be said, but you can also do kernel development in VS Code. I don't know if anyone tried. And pretty much all of this stuff for free, almost free. I don't know if anyone ever tried that. Yeah.
I mean,
so
yeah,
if you
I know
do
VS Code, but I don't do kernel development in it.
yeah, so the way that I work, I have a Windows laptop and a Linux machine, kind of similar to how you work. And VS Code just SSHs into the machine, and you can do all of your kernel development. If you do try to do that, don't use the C extension, the one for Microsoft. It doesn't work. Use the language server from CLangD. It works great. You do have to generate the compile commands JSON. This is a whole topic by itself. I don't know if anyone ever tried to do that, but in order to generate the JSON file, you have to compile the kernel. It's quite annoying. It takes a long time. If anyone knows how to generate it without the actual compilation, that would be very helpful. I didn't find a way.
The compile command file?
Yeah, you do the make compile commands.json, but it just compiles the whole kernel in order to do that. It takes a long time. Yeah.
People remote that.
Yeah, we have people trying to listen remotely. So if you guys are,
You can repeat.
Yeah, so the comment was about the compile commands are like very long to generate, but actually if you combine it with Jesse's approach to have multiple built-in directories, and actually VS Code is quite good with working with like different object directories for the builds and different source directories, and you still like can provide this compile command once, and you don't really update the config very frequently, so you still like can use the old ones for a long time. And for the smaller projects, like with the kernel, it's more complicated, but for the smaller projects, the Clang works very smooth for this code.
we build the kernel with Clang all the time.
Yeah, but sometimes you still have to work with the smaller things like for eBPF development,
right,
or something like that.
Really good idea. I don't know if you guys care, but I just used AI to refactor this function in the driver, asking GitHub Copilot if there was any optimization opportunities in this function. And I don't know if you guys have seen Copilot in action, but it's kind of cool, right? Like running in VS Code in this thing, I just highlighted some code and said, hey, what's wrong? Or what's up with this code? You know, can I make it better? And it made this suggestion that you see in the bottom there of the screen, which is kind of hard to see, but it's dark red. And hello, it just suggested that change and then made the change to the code. Now the question becomes of licensing the stuff. It's fun, but Intel says it's okay.
That was going to be my question. Is it's awesome. Copilot's awesome, right? Like it can do some really powerful stuff, but I have to like turn it on and off manually because there's certain places because of copyrights and stuff.
Yeah, there's definitely, I think, per company going to be able to have to handle that. Intel has actually started giving us leeway to use stuff like this and providing us guardrails, and including working with the back-end companies who are providing the stuff to enforce guardrails at the Intel level, which is really cool. Right? Yeah. And I didn't know that they could do that, and then they did it and then let us go. And pretty much our position right now is that code that is suggested here is code that I wrote because I accepted the change, and that we're not going to worry about it past that.
Right. Yeah, I've seen that too. Like
current position.
In a certain company set it up like as like your site local almost.
Yeah, it's my code.
Yeah.
So is Intel giving you an overview pilot to go with your Copilot so that can check that the Copilot isn't doing something wrong?
They do.
Oh, there is another bot?
Yeah, there's a bot. I've asked it questions and had it give a response and then delete it. And it said was was something dangerous, something.
So I must disclaimer. I love VI, but I do need to talk about Emacs again. Just like VS Code, there's something called LSP I think VS Code uses LSP, language server processor, yeah. Anyway, Emacs uses it too. So if you are an Emacs or now a new SpaceMax user, it will do the, what do you call it? Semantic, it has like semantic tags, right? So it's a little bit more powerful than C tags. It's able to, it knows when you're at a function that's being called or the definition, and it does all the IDE stuff, right? And you enable it the same way, which is you pass compile commands, which is, you can generate, I think this came up earlier, but just to make the point again, you can generate that. There's a script to generate it in the Linux kernel. I don't remember what it's called, but it's like gen compile commands or make compile commands will give you, yeah. And the only other thing I was going to say about that is with LSP, you can choose like these different backends that do the compiling and the parsing in the background. And the one that I use is called CCLS. And it's I think, much more powerful than the sort of stock one that you might be getting. So check out CCLS if you are using this LSP mode.
What was that answer for the question asked that you just?
The problem is that running the script compiles the whole kernel. I wonder if there's a way to generate just a JSON file without actually compiling the kernel.
No, there isn't, because it looks for the object files and then assembles that into the JSON. That's the entire problem. But I think there is a secondary problem, right? So maybe this is the VS Code user group conversation on the side, because no matter what you do, I don't know if you guys see this problem as well. If you do another pull, you just have to walk away from your computer while it's reassembling all the shit, because it'll take like another 2 hours.
Yeah, I haven't edited the kernel in VS Code. I haven't.
Okay. So
it works okay for me. I don't know.
Yeah, it works okay. Yeah, especially.
No, but how do you not reparse the symbols? Somebody has to go and
it's doing it on the remote machine. Yeah.
Okay. Yeah. Sure. Move it to a more powerful server, but this shouldn't be so complicated, I guess, is my point.
I agree.
Because
yeah.
in theory, either we should be able to pull down. It's the kernel, right? Everybody is getting the same damn kernel. The symbols are exactly the same.
I know, but try and clone the kernel onto a Windows machine.
So I don't know if CCLS is different, but it caches the results, right? So it's like instantaneous for me. I never walk away. Like I make a change to a file and it's immediately.
My point is we shouldn't need to do any of that.
Well, yeah, okay, but I'm just saying
it's a static symbol list, right? I mean, every other OS in the world, you can actually download the symbol file and just say, I'm done. Why are we having to recompute a symbol hierarchy of something that isn't moving?
Yeah, you should talk to somebody on the keyboard.
You should definitely like write your own LSP plugin. That would be great.
Does anyone else want to come up and show off their stuff? I mean, it doesn't have to be super earth-shattering, because there's likely somebody here who probably doesn't do it the way that you do.
Yeah, Chris. Somebody's gonna show something.
Or Jake. Is Jake here? Did Jake come
back? Jake is here?
I don't know. I didn't see him.
Yeah.
Maybe busy.
I was gonna. No, not today. Okay.
It's okay. We ate up 30 minutes. If we want, Jamel, we can go hang out outside in the beautiful weather.
My God, Tom is coming up.
Tom's doing it.
Woohoo!
Thanks, everybody. Yesterday.
While Tom's getting set up, I have a maybe dumb question for the audience. So in order to send email to the Netdev mailing list, I have to turn off HTML in the email. But I want HTML on for all of my normal email. Is there any way to configure, I work with Gmail, is there any way to configure Gmail to handle that in a reasonably automatic way, or do I just have to remember to reconfigure Gmail every time I switch back and forth between emailing the Netdev and doing my normal email?
Do you hear that? Did you get that? He says maybe if you specify, Alex, specify addresses that you can filter by saying. And so you've listed Netdev to not receive HTML. What is this, a filter?
Like
Yes, send an email to John. Or actually, I want to know as well. Send it to people at.
oh no, I mean like one of these guys. No, just like the mouse.
Okay, so my laptop is not happy with display. So this isn't my stuff. Yeah, I just wanted to spend a minute, give a little bit heads up. So the WiredGuard presentation reminded me of one of my pet peeves about Linux computing, what have you. So going back, it must have been more than 10 years ago. So I was working on RPS, Receive Packet Steering, and back then we were stuck on single queue devices. So anything we could do to get parallelism up, was a huge win. So we did RPS. It worked out really well. But the thing that annoyed me and annoys me today is RPS works really well when you have a lot of flows. So the more flows you have, the better, because what happens in things like RSS and RPS is they want to do a distribution across queues. And the way they do that, of course, is they look at the 4-tuple TCP or UDP, do the hash, and then do the distribution. So works great if you have lots of flows. And in fact, my first slide actually shows, given enough queues and enough flows, you can achieve an arbitrarily high throughput because you can always add more queues. And as long as your traffic has enough entropy in it, the packets will be placed in fairly good load distribution across those queues. So we can scale in terms of that up to an arbitrary high amount. Problem though is if you get down to a single flow, things like RPS and RSS don't help. So in the WiredGuard example, reverting to making all the tunnel go through a single CPU, that had an aggregate effect when you had multiple tunnels. But if you look, like that slide said, with one tunnel, you actually got worse performance because there's no parallelism. Basically, one tunnel, one TCP connection, one UDP flow, you're stuck with processing on one CPU. And it's a dead giveaway. If you've ever run these experiments, run a single flow through something like RSS or run multiple flows, look at the CPU utilization. What you're likely to see on the single flow example or case is one CPU pegged at 100%, the rest are not really being used. That's the dead giveaway that you have this load imbalance. Now, the single flow is the worst case scenario, and in fact, I call that the single flow bottleneck. But it actually is also a problem with a relatively small number of flows, which was why I asked that question. So if I have 2, 3, 4, 5 flows, sometimes those will be distributed across the queues, but if we're just doing a random hash, then occasionally there's going to be a hash collision. So we actually get a load imbalance even for a few flows. So I may have 5 if they have 5 flows going across 8 queues for 8 CPUs, more often than not, some of those flows are going to have a collision. So I'm probably only using, say, 2 or 3 of those CPUs anyway. So that's a kind of a known problem. I've seen some people try to solve this, at least the multiple greater than 1 problem, by doing some sort of round robin. So the first flow gets assigned to the first queue, the second flow gets assigned to the second. And I think that's kind of the WireGuard solution. Actually manually configure things to do a flow mapping. That works, but the obvious problem there becomes, well, now I need to maintain state or configuration. Whereas if I'm just doing a hash, it's for free. I don't have to do anything. So obviously we like free, don't have to do anything, but we want the performance benefits. So like I said, this has been one of my pet peeves for a while, and I started to look into what's really happening. And if you look at a single flow, let's look at TCP. The reason why we have to send all TCP packets to be processed by the same queue is because we want cache locality of things like the PCB context and the socket. So that makes sense because we don't want to be bouncing around locks or cache lines or anything like that. So it's a trade-off. So by sending everything to one CPU, we're only able to use one CPU for that flow. But on the other hand, we have the benefits of cache locality, so we're now not bouncing cache lines. Now that has the obvious assumption that it's more efficient to put everything on one CPU in order to save the cache locality. Problem with this, though, is if you do the math, your throughput is bounded literally by the inverse of the processing time. So if it takes me 1 millisecond to process a packet, the maximum throughput I can get on a single flow is then 1 million packets per second. That is exactly what we saw when we ran the single flow. The throughput is almost directly bound to the processing time. When you stripe traffic across queues like we do with RSS and have a good entropy, you're still processing each packet in 1 millisecond, but the thing is you're processing multiple of them in parallel. And like I said, if you have enough queues, you can get an arbitrarily high throughput. So that's a diagnosis of the meta problem. And like I said, it's kind of annoying. And we see, WireGuard, we have to have multiple tunnels. I was talking to a company last week, same problem. We need to have multiple tunnels. But there's some obvious direction here. And one direction is given by our friends in the router realm, packet spraying for Falcon UEC. That's kind of a given now. It has the same problem. If you have a single flow going over a network and it follows the same path all the time, then that single flow is only using the resources of one path, where if you just spray randomly, you can use all of the path and get a perfect load distribution. So my thought was, okay, can we apply this to host processing? And the reason it's hard is because of the requirements of, say, TCP, in having to access, say, the PCB. So I have, in canonical terms, it's just a critical region. So when you process a TCP flow, some portion of each packet must be serialized relative to the others because of that access to the PCB. Now, if you look at the whole processing path for TCP packet all the way from Ethernet, IP, TCP to the socket, you can identify those points where we have to have that serialized processing, but everything outside of that, it turns out conceptually you could parallelize, even within the same flow. So the question becomes, is it possible to do this packet spraying? Say, instead of doing RSS, what if we just randomly spray packets across the queues and they process? And like I said, a lot of the processing can be done in parallel. Then it comes down to a question of, for those critical regions, can I make those so efficient, so small, that we get the benefits of that. So the same sort of math applies. If you have, say, one critical region, let's say in TCP, we consider the modification of the PCB. If I look at that little piece of code, and it's little, explain that in a minute. If I look at that little piece of code and able to isolate that, that's the point of serialization. So every packet has to be serialized along that, which means my throughput for that single flow is now bounded by the processing time, not for the whole packet, but now just for that little portion. So mathematically, that's where we get to. So that does put a bound on how fast or the throughput of a single flow, as opposed to multiple independent flows. So there is always going to be a bound, and the bound is going to be related to CPU clock and that. But if I'm able to isolate this flow, now the interesting thing about TCP, and this is one of my favorite things to do, is go way back in time. 1996, Van Jacobson sent an email to Craig Partridge, and it was titled TCP Receive Processing in 30 Instructions. So it was really cool because he gave the TCP fast path processing. It was just a few checks, an update of the PCB, queue the data to the socket. So we're nowhere near that today. I mean, you go through the Linux kernel TCP stack, it's thousands of cycles. So what's the difference? Well, this was back in the day when we were able to isolate functionality, and before we added all the rest of the stuff. But the key point was that isolating that functionality was the key point. And really, when you look at those 30 instructions, the critical region came down to like 6 of them. Updating the, I guess the ACK number, receive window, a few parameters in the TCP BCB. So it actually could be efficient. Now, the question is, how do we implement that such that we can get this this performance up by isolating those critical regions, execute everything else in parallel, and just serialize on those critical regions? Is that possible? First, is it possible in any architecture, and then is it possible in Linux? So what we're doing, my company Panda, we've been working on this for a while. So what we're calling this model is horizontal parallelism. It's different than multi-queue in one way. So multi-queue is basically like RSS. It sends packets for this, one flow to the same queue, another flow to another queue. So it does that normal thing that we expect. Horizontal parallelism does the same thing, except it ignores the flow. It just sends packets across. And then the expectation is that processing will start, and then when we hit the critical region, that's when we have a process of synchronizing that critical region. That's where it gets tricky, because synchronizing critical region in Linux, I need to obtain a lock, I need to get the PCB, do the update, write the PCB. So we're talking multiple transactions across the memory bus, and since this is between CPUs, potentially cache line misses and things like that. So that, though, is kind of in a nutshell. Now, fast forward to today, we have some new advantages. We know, we do know that hardware is becoming more critical. We want to accelerate various parts of TCP. We're kind of running out of steam, what we can do in software, I think. So what we're doing is contemplating, how do you turn this into an accelerator? Say those 6 instructions in Van Jacobson's program to do TCP processing. What if we put those into some sort of accelerator and then have an interaction between the CPU processing the whole packet when it needs to do this PCB update or socket in queue, which is the other critical region, a messaging interface to get to that, get back, and now I have a single memory access going up, single coming back. we never actually even load the PCB into the CPU processing, so there's no cache miss, and it doesn't even take a lock. It's just kind of like we're doing an RPC here to update PCB. So that's what we intend to do in a hardware infrastructure. People obviously want this in Linux. It's a little more difficult because of the generality of Linux. But I think there may be opportunities here. It's not clear to me if we have to integrate hardware directly or if we could find some shortcuts. But I do think that it's kind of a bellwether of the larger space of getting more parallelism, getting more packet spraying. And so that's kind of what one of the things we're looking at.
Thanks, Tom. I want to share my foo and seek your opinion. I recently hit similar problem in a different space, more on the firmware or on the device side. That we are limited by the number of instructions a CPU can execute.
So this is where it becomes a little bit, the world is going to become a little bit fuzzy. What's in the driver, what's in the device, what's in the host. My opinion is we want to look at stack, right? The stack is everything from the application all the way down through the device. And if we can unify all of that, treat that more as one entity, it kind of goes back to the domain-specific accelerators discussion we had yesterday. And the whole problem of offloads, if we can start to integrate hardware into the stack in a more direct way, then I think we have opportunities. And it may be, we may need to do split plane acceleration. So some things are in software in the host, some things are in the hardware. But if we pull it off, at least the fast path does this immediacy. So it's it's an interesting question, like we had this morning. Is TCP inherently slower than the new hardware protocols coming, or is it just implementation interfaces? Fair question. I don't know the answer yet, but
yes, what I was getting into is the way we solved the problem is we had multiple CPUs and a single flow to handle, and the way we split is instead of spraying the packets across 4 CPUs, we actually pipelined them to say memory copy is done by one CPU. So one CPU is just going to copy RX packets. One is going to process the SKBs. One is going to do the TCB processing. In that way, we sort of utilize the power of 3 CPUs just to process the single flow. Is that something explored in Linux kernel, or it's naive? Have you thought in this?
So pipelining is obviously interesting. One of the kind of inherent problems is if all stages of your pipeline, if they're not equal, then you immediately wind up with another type of load imbalance, right?
Yes, we exactly hit that. It's not balanced. So we didn't achieve 3x gain. It was reasonably good enough gain to meet certain. It was like 30 to 40% gain depending on kind of data we get. It was reasonable enough. Is Linux TCP stack in that shape where, or it's just 30 instruction and 10, 10, 10 cannot be cut?
Yeah, I mean, those, a lot of that, there was another case which was kind of interesting. So somebody wanted to do decryption in the host. And I was kind of thinking, well, what if you just receive the packets on one CPU, figure out their inner flow, maybe that was the problem, and then dispatch to other CPUs using something like RPS. I think all of the above is applicable. But my concern is if we really want to get down to this super high performance, and we don't want to completely take programmability out, we can't go to pure hardware solutions to get the high performance. So you do want a CPU involved. Now we're getting into this interesting world. We're getting down such granular performance that even slight things in the CPU, slight variances become a problem. So that's kind of the difference between CPU and a hardware engine. CPUs inherently are going to have more variance, but the trade-off is you get more programmability. So I think it's an open question. Like I said, we have what we think is a path to address this. How generic it can be is always an interesting question. Anything else?
No. Thanks for your food. We'll give you a bar.
All right. Well, thank you.
Thanks. I think the pizza. Thanks for all your patience. But it's pizza time.